Welcome to Solving Large Transportation Analysis Problems with Python. My name is Melinda Meringue, and this is my colleague, Dilesh Mandloy. We're both product engineers on the network analyst development team. That's what I got this for. So today we're going to talk about solving large transportation problems. I'll give an introduction and some background. Then we'll talk about a couple of different techniques for solving large problems. Then we're going to walk through a Python script using local data on our own machines to solve a large problem. Then we'll talk about working with services, and then we'll walk through some other parts of that same Python script which show how you can solve the same type of problem using a service. So we realize that it's quite difficult sometimes to follow along with code in a presentation like this. So all of the code as well as the slides are available for download at this location. So go ahead and take a moment to take a picture of it if you want. We'll show it again at the end in case you miss it. You're most welcome. All right. Let's start with a brief introduction. The ArcGIS Network Analyst extension is the part of the software that's for solving transportation analysis problems. If you're here to learn about utility networks like oil and gas pipelines or electrical or water, you might be in the wrong place. Just wanted to make sure you're aware of that. So the Network Analyst extension has tools for assessing the coverage of different facilities, for optimizing things like your site location or for the routes of fleets of vehicles, and also for point-to-point routing, things like how do I get from point A to point B, what's the closest facility, and solving origin-destination cost matrices. In today's presentation, we're going to be talking mostly about the origin-destination or OD cost matrix. And although we're going to be talking specifically about this tool, a lot of the techniques that we're going to talk about would apply to the other network analyst tools as well. So the OD cost matrix is used for calculating the travel time or distance between sets of origins and sets of destinations. And this tool has the ability to use a time or distance limit, which is important for large problems. And you can also limit the number of destinations you want to find. So instead of saying what's the travel time from every origin to every destination, you could just say what's the travel time from every origin to the closest 5 destinations, for example. So what is a large problem? A large problem is one that can't be solved in one calculation, maybe because it would involve an unreasonably large calculation time, or maybe you hit some memory limits on your own machine, or if you're using a service, maybe you run into some limits of what the service is capable of providing. Usually large problems involve a large number of inputs, and they might also be large because the output is large. So for example, with the OD cost matrix, the result comes back as a table that includes the number of origins times the number of destinations. So if you have 1,000 origins and 1,000 destinations, your output has 1,000,000 records in it. And so the output can sometimes be the large part. Some examples of a large problem involve calculating the drive time from all patients to all medical clinics within 100 miles, or maybe calculating the network distance from every parcel to every other parcel within a city. Today's goal is to create a script that we can use to solve a large OD cost matrix using any number of origins and destinations, and using either local data or a service with or without a time or distance limit, and then combining the results into a single feature class in the output. Now, I've mentioned local solves versus services a couple of times. What am I talking about? A local solve means that I'm solving the network analysis problem on my own computer using my own network data set that's stored on my own disk. So I'm using the computing resources of my machine in order to solve the problem. When I'm referring to a service, what I mean is solving the network analysis problem using some kind of a GIS web service. So the data is sent to the service and the computing resources of the service are used to calculate the result, and then the result is sent back to me. And both of these are a valid way to solve this type of problem, and it really depends on your situation, which one you can pick. And we'll go into this in more detail a bit later. Also, which product should I be using? As you know, we have ArcGIS Pro and ArcMap. We would recommend that if you're solving large problems with network analysis, you use ArcGIS Pro. It's a 64-bit application, so it can use your full memory resources on your own machine. And it also has a much more seamless integration with services. And it stores the results of the network analysis on disk, so it's capable of handling larger problems that in ArcMap might cause memory issues. So ArcMap, on the other hand, is a 32-bit application, so it tends to run out of memory, and it can't use the full resources of your own machine. And if you want 64-bit capabilities in ArcMap, you have to install the 64-bit background geoprocessing extension or use ArcGIS Server. And it's also much less simple to use when you have services. So for the rest of this presentation, we're going to be showing code that's designed to work with ArcGIS Pro, and we're just sort of assuming that you're moving forward into Pro and leaving ArcMap behind to, not using that. So I do want to briefly mention the sort of typical network analyst workflow, just so that as we go forward with the code that we're describing today, you don't get completely lost in there. So a typical network analyst workflow for both local and services solves involves making a network analysis layer, so in this case the OD cost matrix layer, then using add locations to populate the origins and destinations that you want to work with into that layer, then solving it, that's where the calculation is actually done, and then finally working with the output or combining it somehow. And so we'll be seeing this later when we take a look at the code. So now let's talk about some techniques for solving large problems. So some techniques include reducing the problem size, chunking the data, spatially sorting the data, solving in parallel, pre-calculating your network location fields, and using a network dataset layer instead of a catalog path. And I'm going to go through each one of these in more detail. So the first thing to do is to reduce your problem size. You might find out after you've done this that you don't actually have a large problem after all, and then it's super easy to solve. So one thing you can do to reduce the problem size is find only the k nearest destinations. So if you're trying to find the travel time between each origin and each destination, do you really need to find the travel time to all destinations, or do you only care about maybe the 10 closest? If you're trying to present a patient with the medical facilities that it can access, do they need all of them, or do they just maybe need the closest 5? You can also, so the OD cost matrix has the ability to use this to limit the number of facilities to find, or number of destinations to find within the OD cost matrix as one of the parameters of that tool. You could also limit the time or distance. So if you, maybe you don't care about finding the travel time to facilities that are farther away than an hour or 2 hours or 100 miles or something like that. So if you can cut that down, then you can drastically reduce the number of inputs you have to send to the tool. So the OD cost matrix tool has the ability to limit the number of destinations to find, but that assumes that you've already passed all the destinations into the tool as something to look at, and then it will only find the number within that time or distance limit once you've passed them into the tool. But if you want to reduce the number you're even passing to the tool in the first place, you can actually use the select layer by location tool to do a straight line selection first within some reasonable buffer distance, and then only pass the selected features into the tool. So for example, let's say that you want to find everything that's within 100-mile network distance of your origin. Well, if you do a 100-mile or maybe just a 110-mile select layer by location using straight line distance, you're guaranteed to get everything that will be within 100 miles of network distance within that selection. And so then that can drastically cut down the number of points you even send into the tool in the first place. One thing to be careful of if you're using select layer by location in a Python script is that if you run that tool and it doesn't find anything, rather than returning an empty set to you, it will return the entire data set. So if you say select layer by location within 100 miles, it finds nothing, it just gives you everything. So you have to make sure to specially handle that case in your Python script so that you don't accidentally run your tool on everything instead of nothing. Okay, so once you've reduced the problem as far as you can, what you're probably going to want to do is to chunk your data and then solve each chunk one by one, or maybe do that in parallel. So you might come up with a chunk of origins, and then for each chunk of destinations, you would calculate the travel time to the first chunk of destinations, then the second, and so on, then move on to your next chunk of origins. So you'll want to break up your origins and destinations into chunks of reasonable size and then iteratively solve the chunks. And the chunk size really depends on the memory resources of your own machine or the limits that your service has. Some services will have limits to the number that you're allowed to pass in. And don't forget, again, to consider the number of origins times the number of destinations, or more generally, consider the size of the output that will be returned by these chunks. So something you can do to improve your chunking is to spatially sort your data. This allows you to make smarter chunks that will overall reduce the number of times you need to, or the number of iterations you have to have with your chunks. You can use the sort geoprocessing tool to spatially sort data by selecting the shape field as the sort field and using the piano curve method. And this makes it all nice and clustered as it goes through the data set. One thing to note is this does require the advanced license. So if you don't have that, you won't be able to do the spatial sorting. Now, the last couple things I explained were a little bit confusing, so I'm going to walk you through an example that maybe will make it clearer. So let's say that this is the problem that I want to solve. I have about 26 million origins, and those are the purple dots, and then I have about 220,000 destinations. Those are the orange squares. And I want to calculate the travel time from each origin to each destination if the destination falls within 100 miles of the origin. So suppose that I just I say that my chunk size is 1,000, and I select 1,000 origins randomly from my purple origins layer. And they're just kind of scattered all over the country here. So this is 1,000 points, they're unsorted. And then let's say that I want to try to reduce the number of destinations that I have to pass in to my problem for this chunk of origins. And so I'm going to use the select layer by location to select only the destinations that are within 100 miles of these 1,000 origins. So I do that selection, and since my origins are scattered all over the country, I end up selecting about 98% of the destinations that were there in the first place. And so I haven't really successfully reduced the number of destinations that I have to pass in. So for this chunk of 1,000 origins, I'm going to have to run through a bunch of destinations, and it's going to take a while. But let's say instead that I first sort my origins spatially. So now I've sorted them and I've selected a chunk of 1,000, and all of these 1,000 are right here in the Palm Springs area. So that little tiny purple dot down there is 1,000 origins. So then if I select destinations that are within 100 miles of these 1,000 sorted origins, there's 5,653 of them, and that's only about 3% of my destinations data set, as opposed to the 98% that I got when I didn't sort my origins. So now for this chunk of 1,000 origins, I'm only going to need, I guess, 6 chunks of destinations to run through. And I know that the entire rest of the data set is completely irrelevant because it's beyond my 100-mile cutoff. Okay, so now assuming that I've done my chunking and I've done it in a smart way, I need to solve in parallel. And this allows me, instead of doing each chunk one at a time, I can do several chunks at once, and that will ultimately return my results faster. Python makes this easy with the concurrent futures module. And concurrent futures gives you 2 options for doing things in parallel. There's multiprocessing and multi-threading. Multi-threading is not too great for CPU-intensive problems in Python, and it doesn't really work very well with ArcPy, so we don't recommend using that. We recommend instead using multiprocessing. This allows you to spin up multiple processes and run your solves against multiple cores. And it works nicely with ArcPy, and it's really easy to run from standalone Python. A couple of things to watch out for, though, is that if you're trying to write a script tool that runs within ArcGIS Pro, that won't work with multiprocessing directly. You'll have to spin up your process as a subprocess using the subprocess module. You also can't write to the same file geodatabase from multiple processes at the same time, so you just have to be careful about how you're storing your output and use some techniques to make sure that you're not trying to do that. You also can't share the same network analysis layer across multiple processes at the same time. Another thing that you can do to speed up your calculations if you're using origins and destinations more than once. So if you have a chunk and you have your chunk of origins and then you're going to run it against a bunch of chunks of destinations. If you're using local data, this doesn't apply for a service, is you can pre-calculate your network location fields. So what are network location fields? Those are an indication of where each point snaps to the network. So a point is generally just sort of somewhere floating in space, and the network location field is kind of the closest point on your network data set, and that's used as the beginning and end point of the analysis, rather than out in space. And so every time you do a network analysis, you have to be able to determine what these network location fields are. But if you're going to be using the same origin many times, it doesn't make sense to recalculate those network location fields every time because they aren't going to change. So you can use the calculate locations tool to calculate those location fields in advance for your origins. And then when you load your origins into the network analyst layer using add locations, you can use field mapping to just map those existing location fields that you already calculated into the layer, and then it doesn't have to perform that calculation every time. And this will make things run much faster. And then finally, if you've exhausted all other possibilities and done everything else you can to optimize your problem, you should use a network dataset layer instead of a catalog path to a network dataset in your script. So the catalog path, if you use that, it basically, the script has to open the network dataset behind the scenes every time. And this can be especially slow if you're using licensed data or data on a UNC path. So if you instead use the make network dataset layer tool to open the network once and then pass in that layer by referring to the layer name in other tools that use the network dataset, then that can give you a couple of performance improvements. So I'm going to hand this over to Dilesh to talk about some code, but first let me give you an outline of what the code's going to show. Remember, the goal of today is to solve an OD cost matrix of any size using either local data or a service, and then write out the results to a single feature class. And so the script has a couple of key parts. First, there's a pre-processing section where we're going to sort the data spatially and calculate those network location fields. Then we're going to solve the data by we're going to solve the problem by chunking it up and then solve it in parallel using concurrent futures. And then we'll post-process those results so that we can write them all out to the same feature class. And again, the typical network analyst workflow, which will be shown in the script, is that you make your network analysis layer. So we're going to make the OD cost matrix layer, which is where we configure all the settings. Then we'll add locations to it, then solve, and then work with the output. All right, Dilesh, let's take a look at some code.
Check. Thanks, Melinda. So first, I'll show the script that will allow you to solve any size OD problem using a local solve. So again, for those who came in little late, if you cannot see the screen, please come forward. Otherwise, if I zoom in any further, you will not be able to follow the code along. So in this, now I'm going to show you the script which will essentially implement the concepts that Melinda talked about in code. So this is a single file with about 600, 700 lines of code. So again, it can be difficult to follow along. I'm not going to explain every single line, but this script is available at that link that we put up front. We'll also put that link later on. So you can look at it, use it, modify it, adapt it for your needs, and so on. So if you are just here to say, I have this problem and this tool is perfect for me, how can I run it? So this is actually a command line application. So once you get the download, you can actually start the ArcGIS Pro Python command prompt. This script will only work with ArcGIS Pro version 2.3 or later. So that's one requirement, and it will require a network analyst extension license. So once you have ArcGIS Pro 2.3, you change into the folder where you have copied the script, and then you can, the script is called odcm.py. You do python odcm.py-h, and this will essentially print out the command line signature of the tool. So here it takes -o, which is origins, -d destinations, -n network dataset. The documentation is also there along. If you don't want to type along all these parameters on the command line, you can also store them in a file like this, and then you can just say Python odcm.py, this file, and it will just read all the options from here. So that's essentially the user experience on running this tool. So now let's see what are the important parts of this tool. So this tool is made up of essentially four separate, three functions and one class. We will look into it one by one. So first, when the tool starts in, it comes into this CLI function. So let's see what is in this CLI function. So this is defining the command line interface that I just showed you. So all the different parameters, -o, -d, -n, all of those are defined here. And then you go ahead and read all the inputs. So here you read all of the inputs. And then once you have read the inputs, you call the main function. So then this is where the main execution happens. So now let's see what happens inside the main function. So now within the main function, we are doing pre-processing, computing the OD cost matrix, and post-processing. So that's why it's called main. So let's see first what we are doing here is we are creating an output workspace. We are creating a file GDB called outputs.gdb in which we store the result. If it does not exist, we create it. If it exists, we just use it. Now we are doing is pre-processing. So this is the pre-processing that Melinda talked about. Let's see what is inside this pre-processing function. So in this pre-process inputs, we take in the input features, we take in the network data source, the travel mode, and the workspace. So what this is doing first is, it is spatially sorting the inputs. So if you have an advanced ArcInfo license, it's going to go ahead and spatially sort your inputs. And then if it is a local solve, which is what we are checking here, it is going to calculate the network location. So that way, if you are reusing those inputs, it will locate them faster because the location fields are already there. So those are the two steps that we are doing here as part of pre-processing. So now the same thing we do for the destinations. We pre-process the inputs, we pre-process the destinations. Then we are storing the counts of origins and destinations. The counts are then used to figure out what size of chunk we can do. Then we are determining if we are working with ArcGIS Online or with ArcGIS Enterprise. So all this code here is trying to figure out if we are working with a service or with a local data set. We haven't talked about in the slides what it is to work with services, so we'll come back to this code portion later. But if you're not working with a service, you should fall into this else block. Because if you're not working with service, you're working with the local data. And let's see then what is inside this else block. So in this case, here we are doing the chunking. So what we are doing here is, given the count of origins, the count of destinations, and the maximum OD size that you can solve in a single chunk, we are figuring out what should be the chunk size. So let's say this function gets input something like this, 200, 100, 10,000. So let's say you have 200 origins, 100 destinations, and at any given point, your output should not have more than 10,000 destinations, or sorry, more than 10,000 OD lines, output features. So in that case, this function is going to say, okay, let me process the first 100 origins with the first 100 destinations, so the output will only have 10,000 features. Then I take my next 200 origins, process them with, then I take the origins with ID 101 to 200. So next 100 origins, and then process them with the first 100 destinations. So that way, at any given point, I am not doing more than 10,000 output features. So this, the range could be anything, but that's essentially how this function is working. So let's get back to it. Once we have got our chunks, we are creating an iterator so we can go and do the processing in parallel. And now here we have done the pre-processing, we have done the chunking. Now is the time to run those chunks in multiple processes. So as Melinda was mentioning, Python standard library provides a futures module where you have this process pool executor class. This process pool executor takes in an argument which is the max workers. So it's essentially asking how many parallel processes you want. In this case, I am saying that is coming from my input command line. So let's say if I have 4 physical cores on my machine, I may be okay giving 3 cores for this processing and 1 will be left for something else. Or you might say, no, I'm doing this at the end of the day, so just use all the cores on my machine. So in this case, it will be 4. So this process pool executor will get an argument 4 and it will launch 4 parallel processes. Now that you have 4 parallel processes, what do you want to do on each of those processes? You want to run a function called solve OD cost matrix, and to that function, you want to pass your chunk. So let's see now what this function is doing. So this is essentially our main worker function. So if we expand this function instantiates the OD cost matrix class. It will then call the solve method on it, and then it will return the result. So it is essentially solving your OD cost matrix. Now let's see what happens inside this. Wrong button. Okay. So now here we are initializing the class. We are essentially storing certain information that we want to use throughout the class. We are creating a folder, so a workspace, so that we can store all the intermediate file geodatabases in that. We are creating a network dataset layer. So this is one of the optimizations that Melinda talked about. We are creating the OID fields or storing the OID field name so that we can use later. And then we are calling the solve, right, in that function. So now what is happening inside this solve is the 4-step workflow that Melinda talked about. We first create the OD cost matrix layer. We also need to check out, we need to figure out if we are solving against a service or a local data set. We'll see solving against a service momentarily, but if we are working against a local network data set, you need to check out a network analyst extension license. So we are doing that. And then we are first creating the OD cost matrix layer. When we are creating the layer, we are specifying the cutoff, if any, and we are specifying the number of destinations to find. So that way we are only processing things that we need. We are getting the layer object, we are getting the sub layers, and then we are selecting the inputs. So let's see what happens inside this function. So this takes the chunk. So this is where we are saying, okay, I got 50,000 origins. From that, select only the 1,000 that I need. So what we are doing here is we are constructing a where clause so that then we can go ahead and select. Then we create a layer because the layers will have the selection on it. If a cutoff is specified, let's say the problem says only find me things within 100 miles of the origins. So you don't want to process all the destinations, right? So you do a select layer by location, as Melinda was talking about, and then we see if we actually got any selection set back. If we did not get any selection set back, and if you're not checking in this if block, then you are going to get the entire problem, you are going to get all the features in the layer, which will defeat our purpose of chunking. So that's why it's very important to check if there is anything in the selection set. If we have something, fine. Otherwise, go skip that chunk and go to the next one. If you don't have cutoff, well, there is nothing else you can do. So you just then go ahead, create the where clause, and then create the layer based on that, and then you return back this layer. So we have selected our inputs. Then we are doing the field mappings. Field mappings are to load the location fields that we might have calculated, as well as the object ID fields from our inputs, so that when we get our output lines, we can transfer those object ID fields, and then we can join any other attributes if we want to in the future. Once we have done the field mappings, we do load locations. So we are adding the locations onto the layer, origins and destinations. We do the solve and check if the solve was successful. If it was not successful, we return out the messages that were returned for the failure. We also save the results from the solve to a layer file. So if something failed, we can open the layer file and then visualize that layer file to figure out what went wrong. Once we are done with the solve, we want to essentially start the post-processing. Now in the post-processing, what we do is we get the output origins, output destinations, and output lines. And then we transfer the OIDs. So we have the OIDs on our output origins and output destinations, but not on the output lines. So in this process, now here we are trying to transfer our OIDs by doing the joins. Once we have done the transfer of OIDs, we go ahead and return that result to whoever called this function. So that way we are doing the solve, and then we are returning back the results. Okay, so this is what was happening in this solve OD cost matrix function. And remember, this is running on a process pool executor. So every process is running a copy of that function. And that way, if you have 4 processes running, 4 of them are producing or computing your chunks in parallel. And then we are eventually, once that is done, we get all the results in a list. And then we iterate over the list and get the individual result and then merge that into a single feature class. So we iterate over the results, and then once we have, then we go ahead and merge them into a single feature class by using the merge tool. And then once we have done our merging, we clean up all the intermediate data, and then we go ahead and complete our process. So that's in short how we are doing first the pre-processing, figure out the chunking, figure out how many chunks we want to run in parallel, run those chunks, collect the results, and then do the cleanup. So Melinda talked about local solve. I showed you in code how you can do local solve. Now let's see how you can do the same problem if you are working with services. So we said you had 2 options, local solve or a service solve. So which one do you pick? So there are 3 different options. Local solve, services can be on ArcGIS Online, or the services can be in your own ArcGIS enterprise running on your own servers. So which one to pick when? So there are these bullet points will help you make the right decision, but some of the options are pretty clear. If you don't have any street data with you, then the only option you have is ArcGIS Online, because ArcGIS Online provides you with the street data. If you don't have a network analyst extension license for ArcGIS Pro or ArcGIS Enterprise, then again ArcGIS Online is the option, because ArcGIS Online does not require a network analyst extension license. It only needs service credits to be able to use the services. But let's say if ArcGIS Online service imposes limits on this problem that you can solve. So you can only solve 1,000 origins and 1,000 destination in a single request. So if you have a very large problem, you will have to chunk it up in a lot of chunks, and it might take significant longer. Also, the number of credits might be too large that you may not have that many credits. So maybe ArcGIS Online is not always the better option, but sometimes it is the good option. Local solve is when you have your own street data and you have the network analyst extension license for ArcGIS Pro. If you don't have ArcGIS Enterprise, then local solve will be the option. If you have only one machine where you can run this thing and you only have ArcGIS Pro running on that machine, then local solve is the only option available to you. But if you have ArcGIS Enterprise, then you can even speed this problem further up. Because ArcGIS Enterprise can run on multiple servers, instead of one server, you could have a bank of servers, and each of the servers can process a chunk for you. So that way, if you have servers and you have them set up correctly, then you can run this on ArcGIS Enterprise, and that would be the fastest, because you will not have the ArcGIS Online limits, and you can have as many servers as you want, and then you can start running as many chunks in parallel as the number of servers that you have. Let's say if you're working with ArcGIS Online, you have to worry about 2 things. One is ArcGIS Online service requires credits and they have limits. So for the OD cost matrix service, the limit is 1,000 origins and 1,000 destinations. So if you pass more than 1,000 origin or destinations, you will get back an error. So in your script, you have to make sure that the origin and destination count is always less than or equal to 1,000. And ArcGIS Online requires credits. So every time you make a successful request, ArcGIS Online will deduct credits. So let's say you're doing 1,000 by 1,000 OD, so that will create 1 million entries, and the credit cost for that would be 500 credits. So you have to evaluate if you're doing the OD problem based on the size, how many credits you need, and if it is worthwhile to get those credits, or it is worthwhile to get ArcGIS Pro and invest in street data and do the analysis locally. Some things for you to evaluate. If you're using ArcGIS Enterprise, you need to publish the OD cost matrix service to your ArcGIS Enterprise. So how do you do that? ArcGIS Enterprise ships with version 10.6 or later, ships with a tool called Publish Routing Services. I've provided a link so you can find out where that tool is. This tool takes in a network data set and will publish the OD cost matrix service in your ArcGIS Enterprise. The tool publishes the service with default parameters. So if you are using that service to solve large problems, there are certain settings that you should configure. So the first setting is the number of service instances. This will depend on the number of physical cores you have on your server and how many servers you have. Let's say your servers have 4 physical cores, then you would want to change this number to 4. Minimum 4 and maximum 4. So this will make sure that you have 4 service instances running on your server. If you have 3 servers, it will start 4 instances on each server, so you'll end up with 12 processes. By default, this value is minimum 1, maximum 2, which means you will only get 1 and up to 2, and that will not utilize your server. So you should be noting this and changing this value down based on the number of cores you have on your server. The next setting is the execution time for a request. So by default, this setting is set to 10 minutes, which means if a request takes more than 10 minutes on your server, it will time out and return an error. Now, if you're solving a large OD, the request can take more than 10 minutes. So I recommend you set this to a higher number, like an hour or 3 hours, depending on what you see fit. But keep a note of this setting and make sure you change it. Otherwise, you will get errors when solving large problems. The last one is the number of features actually returned from the service. So your service can produce 1 million records. The processing can produce 1 million records, but the service by default is configured to return only 1,000 features, which means it's going to return an error. So you should change this value to the maximum chunk that you see that your service can produce, let's say 1 million. So you should set it to that number or higher. So now let's look at that same script, but look at the portions that are relevant to solving against services. So we were in the main function. So solving against a service or local data is same for the most parts, but there are only few changes that you need to do. So we do the same pre-processing, and then here we determine if we are working with ArcGIS Online or we are working with ArcGIS Enterprise. Now the difference between local solve and service solve in terms of code implementation is the network data source. So this is a command line parameter. If you're working with a local network data set, this would be the catalog path to the network data set. If you're working with a service, this will be the URL of the portal. Either arcgis.com or whatever URL your portal is running at. So that's what you get, and then based on that you figure out if it is a service solve or a local solve. Now if it is a service solve, you get the portal information, and from that you can figure out if it is ArcGIS Online or your own portal. So that's how we are figuring out if it is ArcGIS Online or not. Now if it is ArcGIS Online, as I mentioned, you need to worry about service limits. So how do you get those limits? Well, you can hard code these limits, or you can even use some code to get those limits. So let's look at how you get the limits. So here we have a function called getToolLimits, which is essentially calling this function called arcpy.na.getWebToolInfo. Now this is something new that we added in Pro 2.3. So this tool essentially takes the name of the service. In this case, it will be OD Cosmetrics, the URL against which the service is running, so ArcGIS Online, and it will return the limits supported by the service. So this is a lot better than hard coding the limits. So that way in future, if ArcGIS Online changes the limits, your script will automatically adapt to those limits. So based on those limits, it's a dictionary. So you get the maximum number of origins and the maximum number of destinations. And now you create the chunks based on the origin limit and the destination limits. So let's look at this chunking function. So the previous chunking function that was working against the local solve took a max OD size as an option along with the count of the origins and destinations. This function, because in ArcGIS Online, the limits are on the number of origins and destinations. So we are taking the max origins and max destinations as parameters. And then we are saying create the chunks. So for example, you are processing, let's say 1500 origins and 1200 destinations. And we know in ArcGIS Online, the limit is 1000 origins and 1000 destinations. If you don't chunk and pass the entire 1500 origins and destinations, you are going to get an error. So what this function would do is it will make sure that at any point you're only passing 1000 origins and 1000 destinations. So for this particular input, it will return something like, okay, the first 1000 origins with the first 1000 destinations, the first 1000 origins with the next 200 destinations, the next 500 origins with the first 1000 destinations, and so on. So it's creating chunks, and it is making sure that at any given point, any chunk does not have more than 1000 origins and 1000 destinations. So we have the OID ranges. Then we get the input number of workers. So we make sure, like ArcGIS Online will block your IP if you're sending more than 4 concurrent requests from a given IP. So we make sure that we don't submit more than 4 requests at a given time. So we make sure that it is not more than 4. And then we go ahead and do the solve. So then we run the exact same code, process pool executor, and then it goes into that solve OD cost matrix, which will again go into the solve function here. And in this solve function, we are just saying if it is a service, we don't need a network analyst extension license on the machine where we are actually running this code. So we don't check out the license. And then from that point onwards, everything else is the same. We also figure out the network data source. So if it is a service, it is the URL. If it is the local case, it was the network dataset layer that we had created. Beyond that, the code is exactly the same. We call the make OD cost matrix layer. We call add locations. We do solve, and we do post processing. With the, let's get back. So if we are working with the enterprise services on your ArcGIS Enterprise, then again, the steps are exactly the same. The URL will be different and there will be no limits, but there will be still an OD size limitation, like the maximum number of outputs you can actually return from the service. So that was all that I had to talk about this code sample. So now I'll move back to the slides.
All right, thank you, Dilesh. So that's pretty much the wrap up of our presentation, but just to review the techniques for solving large problems: reduce the problem size, chunk your data, spatially sort your data, solve in parallel, pre-calculate your network location fields, and use a network dataset layer. And there again is the URL where you can get the slides and get the code sample. So with that, we'll open it up for questions.
Yeah, and please fill out the survey so we know how we did and what we can improve on next time we offer this thing. So yeah, we'll open up for questions. You can come here, ask us questions, or ask questions from where you are. And thanks for coming, and have a nice rest of the conference.
Do you have a question?
Yeah, sure.
Yeah.
So obviously, I'm assuming these techniques can also be used for other things within network analysts, like a vehicle routing problem, or you have a lot of service areas that you want to search for. Similar workflow, just changing.
Yes, so the question is, would these techniques be applicable to other kinds of analysis that you can do, like vehicle routing problem or service area? And the answer is absolutely yes. Not everything would be applicable, but most of it, like spatially sorting your data and solving things into parallel and then combining the results. Let's say if you're doing a vehicle routing problem, then breaking that problem up into smaller regions would be slightly different. Like you may separate it out by geographies, like you're doing a county at a time or you're doing a state at a time. So that portion will be different. But once you have your chunks, then processing them using process pool executor and then combining the results, those things will be the same. Yeah, question.
How long does it take to run?
So the question is, how long does it take to run? So the whole problem that Melinda had, it was like 240,000 destinations and some. So that took about 36 hours to run. But yeah, it ran.
That was locally?
That was locally. I didn't use a server. I ran it on my laptop that has 4 cores. I set the number of concurrent processes to be 4, left it on Friday evening, came back. It finished before I came back on Monday, about 36 hours. But I had the results, and then I can just look at them. So, yeah. Yes, question.
Actually, I have a question about the select by location.
Okay.
And I always thought when we were talking about how the select by location only selects it as a straight line,
Yeah.
I always thought it was a buffer. Like if you select a point and select, it will become a circle. So if it is, if you have a buffer feature, it will become a, what is that shape? I do not know in English. But it's like maybe an ellipse sign.
Yeah. Yeah, so the question is the select by location. We said it uses straight line, but you can visualize it as a circle. Now, straight line here is the way it is measuring is the straight line technique. Right?
It's a radius.
It's a radius. What we mean by straight line is the radius, as opposed to if you think of a service area, that's actually following the streets. So it's not as the crow fly distance, right? So when you're saying a point is within 5 mile buffer distance, what does that mean? It's like if you draw a straight line from this point, it will be 5 miles, right? So that is the radius, and that radius you can see as a circle. Yeah. So yeah, what you have is correct. The idea that you have is correct. The way we said it was slightly different. We think of it in terms of distance. It's like either travel distance or straight line Euclidean distance. And so that's why we talk in terms of distance and not in terms of circle. But yes, select by location is doing circles or ellipsoid if it's a line, or it's like the polygon buffer around polygon. So yeah, it is doing that. Yeah.
Thank you, I understand. Thank you.
All right, if there's no further questions, thank you very much for coming, and feel free to come up and ask us individual questions.